This is the third video in adding subtracting rational expressions. In video number 1, we saw how to add or subtract rational expressions that have either the same denominator or the opposite denominators. In video number 2, we saw how to find out the LCD when denominators are not same and how to write equivalent fractions. In this video number 3, we will look at examples of actually adding and subtracting rational expressions where denominators are not the same. So to find the LCD of a rational expression, begin by factoring each denominator into its prime factorization. The LCD is product of every factor from each expression raised to the highest power found in each expression. Okay. So here's two examples of finding the LCD. I'm going to leave those up to you, and I'm going to start with adding and subtracting rational expressions. So here we're going to be adding and subtracting rational expressions. So our goal is to first find the LCD, then write each rational expression with the common denominator, then add or subtract numerators, and leave the common denominator as a denominator. In this case, x minus 4 cannot be factored anymore. So I'm going to try to find the LCD. X minus 4 cannot be factored anymore, and x plus 2 can also not be factored anymore. So LCD in this case will be product of x plus 2 and x minus 4. So when I'm trying to add these two fractions, I need the common denominator, and that common denominator will be x plus 4 times x minus 4 times x plus 2. So the common denominator is x minus 4 times x plus 2. X minus 4 times x plus 2. Let's do a middle step as well. I'm going to be not doing it every time, but my goal is to write both of these fractions with the common denominator as the denominator, with the LCD as the common denominator. With LCD as the denominator. So I'm going to write two equivalent fractions. What does the first fraction need to be multiplied with? Well, both numerator and denominator need to be multiplied with x plus 2 in the first fraction. And the second fraction, numerator and denominator, need to be multiplied with x minus 4. So leaves me with x squared plus 2x. And here we are going to be dealing with binomials. So we're going to be foiling first, outer, inner, last. So that is x squared minus 4x minus x plus 4. Now we have the same denominator for both the fractions. We can go ahead and combine the numerators. So I'm going to write all the numerators together and then combine the like terms. Negative 4x and negative x gives me a negative 5x plus a 4. X squared plus x squared are also like terms. So 2x squared, 2x and minus 5x. 2x minus 5x would be negative 3x plus 4 over x plus 2x minus 4. Usually, I would try to factor the numerator and see if it's possible to factor it further. In this case, looks like it's not. There isn't any two numbers that will multiply to give me positive 8 and add up to give me negative 3. So it's not factorable anymore, and this will be my end product. This will be my final answer. But if it is factorable, we would go ahead and factor. If you want to, you can go ahead and do foiling in the denominator and multiply them out, but it's not needed, not required. I actually prefer if you leave it in the factored form. That tells me that you made sure that your answer is in the lowest terms. That means there's no common factors between numerator and denominator. Here's our next problem. I want to find out LCD here, but before we find out the LCD again, we've talked about that we need to do prime factorization of each denominator. So let's think about what numbers multiply to give me negative 6 and they add up to give me positive 1. So factor it out, and then x squared minus 4 is difference of squares, and that factors into x plus 2, x minus 2. When I'm thinking about LCD would be x plus 3, x minus 2, and then we have x plus 2, x minus 2. Remember, when you write the LCD, so when you're trying to figure out the LCD, we bring, these are my denominators, we bring each unique factor down with the highest exponent. So my unique factors are x plus 3, x minus 2, and x plus 2. And that would be my LCD. Okay, look at the last video. If you're having hard time finding the LCD, go back to the last video and see the examples. We did detailed examples on finding the least common denominator. So in this case, my least common denominator is going to be x plus 3 times x minus 2 times x plus 2. Now, once I have the common denominator, I can combine the numerators. So I'm going to write it as a single fraction. I'm not going to write equivalent fractions like I did in the last example. So I'm going to skip one step in the middle and go straight to the common denominator. X plus 3, x minus 2, and x plus 2. That's going to be the denominator of new fraction. Well, what was missing in the first fraction? The first fraction needs to be multiplied, both numerator and denominator, with an x plus 2. The second fraction needs to be multiplied with an x plus 3. Okay, just be a little extra careful now because I do have, binomials and binomials. I am going to be using parentheses to make sure I do distribute the x plus 2 into another x plus 2 and I distribute x minus 1 into x plus 3. Okay, when we multiply these, we're going to be using foiling. First, outer, inner, last. Okay, first times first, x times x is x squared. Outer times outer is x times 2 is 2x. Inner is 2 times x, which is 2x. And last is 2 times 2, which is 4. And there's plus in the middle, which is nice. But if it was a subtraction, I had to be extra cautious because it will turn everything else negative that comes after it. But because it's plus, so that's nice. And we don't have to worry about that. So let's go ahead and do the foiling for the x minus 1 and x plus 3. X times x is x squared plus 3x minus x minus 3. Let's go ahead and combine all the like terms we have. Looks like x squared and x squared are like terms. And then 2x, 2x, 3x minus x, those are like terms. So x squared plus x squared is 2x squared. 2x plus 2x is 4x. 4x plus 3x is 7x. Minus x is positive 6x. 4 minus 3 is plus 1. And I would try to factor the numerator again to see if it's factorable. Looks like in this case it's not factorable. Numerator is not factorable. But if it was, I would factor it further to make sure if I have any common factor between the numerators or denominators. All right, next example, a minus 2 over a squared plus 5a plus 6 minus 2a minus 3 over 3a squared plus 9a. Okay, first thing I'm going to do is I'm going to factor the denominators. It's easier to find out LCD because my goal to find the LCD, we need to do prime factorization of the denominators, right? I can pull out a 3a, a plus 3 in there. Now, let's do some work to find the LCD. My denominators are a plus 2, a plus 3a plus 2 in the factored form, and then 3a times a plus 3 in the factored form. Remember, LCD is each unique factor coming down with the highest exponent. Well, 3 has the highest exponent of 1, a has the highest exponent of 1, a plus 3, and then a plus 2. This is all going to be my LCD. Now my goal is to write this entire expression as a single fraction with the new denominator that we just found out. So I'm going to write it with the denominator 3a times a plus 3 times a plus 2. So what is missing in the first fraction? Looks like in the first fraction I already got a plus 3, I already got a plus 2, but I do need to multiply both top and bottom with the 3a to have this LCD as my denominator. And the second fraction does have a 3a, does have an a plus 3, but I do need to bring an a plus 2. I need to multiply both numerator and denominator with a plus 2. Okay, be extra careful in this case because of the subtraction sign in the middle. It is going to turn everything into opposite that comes after the negative sign. So I'm going to put big brackets around whatever terms I have after the negative sign. Okay, let's go ahead and distribute 3a here. 3a times a is 3a squared minus 3a times 2 is 6a. Okay, big bracket, and here I'm dealing with a binomial and a binomial. That means I'm going to have to do foiling. Foiling says first, outer, inner, last. First times first is 2a times a, which is 2a squared. Outer times outer is plus 4a. Inner times inner is minus 3a. Last times last is minus 6. All right, let's go ahead and combine the like terms, and 3a squared minus 6a minus 2a squared. This negative sign is going to turn everything into opposite, and then I will combine the like terms. Minus 4a plus 3a plus 6 divided by 3a times a plus 3 times a plus 2. 3a squared minus 2a squared is a squared. Negative 6a, negative 4a is negative 10a, plus 3a is negative 7a, and then plus 6 over 3a times a plus 3 times a plus 2. Is it possible to factor the numerator anymore? Yes, looks like the numerator is factorable, but would that help me anyhow? Would I be able to cancel any common factors between numerator and denominator? It doesn't look like, but it's totally okay to go ahead and factor the numerator to make sure that you don't have any common factors between the numerator and denominator, and then stop at that point. Example number 4. Okay, again adding, subtracting, and now we have 3 terms. Okay, so we already know the first denominator is already in the factored form. The second denominator is already in the factored form. The last one is not in the factored form. So my denominators in this case, denominators are a minus 2, a plus 2, a plus 2, and a minus 2. So when I write my LCD, remember we're going to bring each unique factor down with the highest exponent. So bring each unique factor down with the highest exponent. That would be a plus 2 times a minus 2. So that means my LCD is a plus 2 times a minus 2. In the next step, I'm going to write all 3 fractions into a single fraction with this new denominator, which is my LCD as my denominator. The first fraction needs to be multiplied, both numerator and denominator, with a plus 2. The second fraction needs to be multiplied with a minus 2. And the last fraction already have the same denominator, the common denominator. So here we are, 5 times a plus 2 plus 5 times a minus 2 minus 6. That's what I have when I combine the terms on the numerator. Now in the next step, I'm going to distribute here, combine all the like terms. 5a plus 10 plus 5a minus 10 minus 6 over a plus 2a minus 2. 5a plus 5 is 10a, positive 10 and negative 10 is gone. 10a minus 6 over a plus 2a minus 2. If I am able to, I can actually factor out a 2 from the numerator, but then I wouldn't be able to cancel anything between the numerator and denominator, so I'm going to leave it at this point. Now, if you really want to factor a 2 from the numerator, you can, and there's another way to express this answer. You can pull out a 2 from numerator, 5a minus 3 over a plus 2a minus 2. Or you can also leave it as 2 times 5a minus 3 over a squared minus 4. Or you can also leave it as, all these are possible answers. They all are correct. They all are equivalent. 10a minus 6 over a squared minus 4. Okay. And we cannot cancel anything between numerator and denominator again because we have a binomial and a binomial. We don't have any factors sitting in the isolated form. Let's look at example number 5 here. For example number 5, x over x squared minus 4 minus 5 over x squared minus 4x plus 4. So let's go ahead and factor x squared minus 4. The factors are going to be x plus 2, x minus 2. And two numbers that multiply to give me positive 4. It's a trinomial, 3 terms. So two numbers that multiply to give me positive 4 and add or subtract to give me negative 4 are negative 2 and negative 2. So remember, we wanted to write, let's go ahead and write all our denominators. Remember, we said we want to write our denominators with the exponents wherever we can. So instead of writing x minus 2 times x minus 2, I'm going to write x minus 2 squared. What's going to be my LCD? In this case, bring each unique factor down with the highest exponent. And that's going to be my LCD. So that means I want to change the entire, I want to write it as a single fraction with this LCD as the denominator. So what's missing in the first fraction? Looks like the first fraction already has 1x minus 2 and 1x plus 2, but it does need to be multiplied with an x minus 2, both numerator and denominator, to get to the common denominator. And the second fraction already has x minus 2 and x minus 2. Second fraction does need to be multiplied with x plus 2 and x plus 2. Again, extra word of caution, because I have the negative sign, I'm going to put the brackets to make sure the negative gets distributed to everything that comes after. Now it is time to simplify, and I'm going to go ahead and distribute the x in here. X times x is x squared minus 2x. And then I have minus, in parentheses, 5x plus 10. Okay, let's see. X squared minus 2x minus 5x minus 10 over x minus 2 squared, x plus 2. So x squared minus 7x minus 10 over x minus 2 squared times x plus 2. Let's see if I can factor the numerator anymore and cancel out the common terms. Two numbers multiplying to negative 10, adding up to negative 7. Well, doesn't seem like, because negative 5 and negative 2 will not add up, will not multiply to negative 10. So we cannot factor it anymore, and we would leave it at this point. Okay, because think about two numbers multiply to give you negative 10, add up to negative 7. Well, they can be negative 5 and 2 or 5 and negative 2, but then they would not add up to negative 7. But if you want to multiply to, if you make them both negative, then they would add up to negative 7, but they would not multiply to negative 10. Okay, so no further factoring is possible, and we will leave it at that point. Let's look at example number 6. Y plus 2 over y minus 3 plus 2. Well, there's nothing in the denominator here, so I'm going to put a 1. And we can clearly see my common denominator will be y minus 3. So the second fraction has to be multiplied. Both numerator and denominator of second fraction needs to be multiplied with y minus 3. And we're left with y plus 2 plus 2y minus 6 when we distribute here. And y plus 2y is 3y. And 2 minus 6 is minus 4 over y minus 3. And that's it. 3y minus 4 over y minus 3 is all we're left with. We'll look at next example we're going to do is number 8, and then we'll go to number 7. Okay, again, I'm going to go ahead and factor the denominators. Y minus 9, y plus 9. You have to be, your factoring skills have to be really solid. If your factoring skills are weak, you will not be able to do well with the rational expressions. Okay. Now, I don't need to do a whole lot of work here to figure out my LCD, because one denominator is y minus 9 and y plus 9. The second denominator is 2 times y plus 9. LCD will be 2 times y plus 9 times y minus 9. That's going to be my LCD. And I want to write this entire fraction with this new denominator, 2 times y minus 9 times y plus 9. Now, how do I convert the first fraction into, how do I change this denominator into this LCD? All I need to do is multiply numerator and denominator with a 2. How about second fraction? The second fraction already has a 2, but I do need to multiply numerator and denominator with y minus 9. 27 times 2 is 54, and 3 times y is 3y, and 3 times 9 is 27. So 3y minus 27. 54 minus 27 is 27, positive 27, over 2 times y minus 9 times y plus 9. Now, well, further factoring is possible because I can take out a 3 from the numerator, and we are just left with a common factor between numerator and denominator. Once we cancel that out, 3 is in the numerator and y minus 9 is in the denominator. That's our end product. Okay, another example. This one, factoring could be a little bit more work here. So here's example number 7 that we're going to look at next. So let's go ahead and factor the denominator. It is a quadratic in 2 variables. So for a moment, think about factoring x squared plus 4x plus 4. What are the factors for x squared plus 4x plus 4? Now the polynomial we're dealing with it's a quadratic trinomial in 2 variables. It is quadratic in x and in y as well. But x plus 2 times x plus 2 will give me x squared plus 4x plus y. Plus 4. Now the only thing we have to do here is, because we want to get 4y squared at the end, we would be adding y's at the end of our 2 parentheses. So it's going to be x plus 2y squared. I'm going to write it with the parentheses, write it as an exponent and parentheses. And x squared minus 4y squared is x plus 2y times x minus 2y. Now pause for a minute and think about what is going to be the LCD in this case. Remember, LCD is each unique factor written with the highest exponent. So it would be x plus 2y squared times x minus 2y. I'm going to write it as a single fraction now. I'm going to write it as a single fraction, x plus 2y squared times x minus 2y. So let's go ahead and multiply first fraction, numerator and denominator, with x minus 2y to get to the common denominator. And then x plus 2y, x plus 2y. All right, so here we go. We're going to have to FOIL these out. Numerators, x times x is x squared plus 2xy minus 2xy, first, outer, inner, last, minus 4y squared. Okay, minus, because I have a negative sign, don't forget to put the brackets because it's going to turn everything into opposite. 2x times x is 2x squared. 2x times 2y is plus 4xy. All we have to do is distribute the negative and combine the like terms. X squared and 2xy and minus 2xy is gone. Minus 4y squared minus 2x squared minus 4xy over x plus 2y squared, x minus 2y. Any like terms? Yes, these are my like terms. So negative x squared minus 4y squared minus 4xy over x plus 2y squared, x minus 2y. We can factor out the negative from the numerator and leave it in the front of the fraction, and that would turn our entire numerator into a positive. All the negative signs will turn into positive. X plus 2y squared times x minus 2y. And there's negative in the front, don't forget that. Right, that would be it. And there's one last example we're going to look at. Again, that's for adding or subtracting rational expressions. My first step is to factor the denominators. Two numbers that multiply to give me -6, add up to give me -5 are x plus 6, x minus 1. You cannot use -3 and -2 because they will multiply to give you +6, okay? So don't be mistaken. Two numbers multiplying to give me -5, adding up to give me -4 are -5 and -1. And then we have x plus 1 in the numerator. Now here, yeah, x squared plus x minus 5x, which would be -4s. That's correct. So before proceeding further, we can see here 6 and -1 will multiply to give you a small correction here. We would have -6 and +1. So double check your factors because we wanted them to add up to -5, right? Yeah, we wanted them to add up to -5. Now, let's see what's going to be the LCD in this case. Just by looking at them, we can tell the common denominator gets each unique factor raised to the highest exponent. So we're going to have an x minus 5, we're going to have an x minus 6, and an x plus 1. So I'm going to write this entire fraction with this new denominator as with LCD as my denominator. So what do I need to multiply the first fraction numerator and denominator to get to the common denominator? Well, we need to multiply with x minus 5. How about the second fraction? What do we have to multiply numerator and denominator with to get to the common denominator? X minus 6 in the second fraction. So let's go ahead and do the foiling here. First, outer, inner, last. First times first is x squared. Outer times outer is 8x. Inner times inner is -5x. Last times last is -40. And same thing here, first, outer, inner, last. Remember the word FOIL, first, outer, inner, last. X times x is x squared. Outer times outer is plus x minus 6x minus 6. Okay, let's see. Combine the like terms. X squared plus x squared is 2x squared. 8x minus 5x is 3x. Plus x is 4x. 4x minus 6x is -2x. And minus 40 and minus 6 is minus 46 divided by x minus 5, x minus 6, and x plus 1. Now, go ahead and try to pull out a 2 from the numerator. See if we can factor it anymore. But it does not look like. It looks like it's not factorable anymore. And we're not able to factor it anymore. So we'll just have to stop at this point. We can leave it in this form. No need to multiply the denominators. It's actually better to leave it in the factored form. Then we know for sure that we have checked our work and made sure there is no common denominator here.